First, we have to look for the binomial Q formula to then substitute the values for the function. Once we have the function with the Q values, we have to search for the derivative formula to substitute the values with the limit restriction of h equal to 0. When we have the values with the limit restrictions of h equals 0, we start to do the equation, substituting and deleting the same values like t cubed and t. Then we have to multiply h for the equation to then have the final result.
To look for the equation of a tangent line to the position at time equal to 1, we have to use the formula y equals m multiply x plus b and substitute the values of the original function and derivative.
So, what is a tangent line? A tangent line is the line that passes through here, just in the border with our equation. It never touches, but it shows us where is the border. So why is this line important? It is important because it leads to the limit concept, which in turn leads to the concept of derivatives. So we already know that our tangent equation will be this: y equals to 2x minus 2. The question that we have is find the equation with t equals to 1, which is t equals to x, so our point will be 1, 0. We already know that the slope of the first slope is 2, so the formula to the second slope is m2 equals to minus 1 over the first slope, which will be m equals to 1 minus 1/2. Now, knowing this, we can do the procedure. It's y minus y1 equals to m times x minus x1. Substituting will be y minus 0 equals to minus 1/2 times x, because it's just a volume, minus 1. Y, because 1 is this point, this y will be this point. So our final answer will be y equals minus 1/2 x plus, we have minus plus 1/2. So
the perpendicular to the tangent line at the point of tangency, because the slopes on the perpendicular lines are negative reciprocals of one another.
Is a cubic polynomial with a maximum and minimum point, where the domain is all real numbers for t and the range for all real for x. The degree of the polynomial and provide a general idea of the shape of the function indicates the intersections with the abscissa.
Step number 1. We search in internet the formula and how to resolve the function. Step number 2. We apply the formula with the respective information we have to solve it. Step number 3. We substitute the values that we have for the formula. Step number 4. Once we don't have any values to change, we clear the equation, then we have the final result.